Good morning, dear students of Class 8. I am a science teacher, DPS sir, from LPM Public School, Golavaja, Gorakhpur. Student, today I am going to explain the chapter 13, that is chemical effects of electric current. Yes, student, chemical effects of electric current. So, in that, I will explain today about the topic difference between conductor and insulator. So, student, one thing I want to say that the material through which electric current could pass, the material through which electric current could pass is called the conductor, or you can say good conductor of electricity. And the material through which electric current doesn't pass is called non-conductor of electric current. That means it is also known by another name, insulator. So student, conductor and insulator is clear to you. Again I am repeating, the substance through which electric current could pass is called the conductor, and the substance through which electric current cannot pass is called insulator. Next student, demonstrate the use of the electric tester. What is the use of electric tester? To detect that whether through the circuit electric current is flowing or not, our instrument is made by the help of which we can detect when we touch that wire or that switch or that plug, to just check that whether the current is coming or not, whether the current is flowing through this wire, through this circuit, coming to the switch, coming to that appliances or not. We should take the help of an instrument named tester, in which there is a bulb, small bulb, that indicates that electric current is present in that appliances, in that circuit or not. So that is called the tester. Now, student, next I will in this chapter I will also explain you that the experiment how liquid conduct electricity. That to show that how a normal water, tap water, conduct electricity, not distilled water. Pure water, tap water, normal water can conduct electricity. So let's start, student. Electric current is the flow of electrons. Electric current is the flow of electrons. The passage of electric current through the substance is called the conduction. The passage of electric current, through the, what you can say, appliances or through the substance is called conduction. Means the passing of electric current is called the conduction. Conducting material behaves differently when electric current is passed through them. Some decomposed and some are not. So student, now liquid, just I told you that liquid conduct electricity. In that case, all the solid allowing electricity to pass through them are mainly metals and alloys. Means, or as a solid, we know that in solid material the electric current passes. Just like you can say metals and alloys are those substances through which electric current could pass, and those conductor through which the electric current passes are either metallic or alloy, that is called the metallic or electronic conductors. So The circuit, which is made up of either metals or alloys through which electric current could pass, that is called the metallic or electronic conductor. In solid, electricity is carried by when electrons flow through it. We say that electric current is passing through it. No chemical change occurs when an electric current passes through a metallic conductor. If any current is passing through a metallic conductor, that didn't show any chemical reaction happening in that. Okay, student. So no any chemical change occurs when an electric current passes through a metallic conductor. The material which allows the electric current to pass through them is called the good conductor of electricity, and the metal through which electric current could pass is called the good conductor of electricity. Example, says copper and aluminium. The material which do not allow electric current to pass through them is called the poor conductor. Just for example, rubber, plastic, wood, like this type of things. Now, student, I just told you to prove that the water can conduct electricity. So for that, just collect tap water and put some salt in that, or either add lemon juice, or either uh, it is saying take different types of liquid. Take different types of liquid. Take a normal tap water, take a salty water, take a water in which lemon juice is mixed or only lemon juice is there. Take kerosene oil and take distilled water. Okay, take a battery or you can say cell, attach the positive terminal of the cell with the bulb, and again attach a next wire, attach the positive terminal of the battery to the bulb with a wire, and again attach the negative terminal of the battery and put it in that. Either you have taken water or lemon juice or salty water, or you can say kerosene or distilled. Take different vessels, different types of things. In one you take tap water, in other you can say you can take the salty water, in other you take kerosene oil, in other you take lemon juice, in other you take distilled water. So after completing the circuit, without joining the two wire, just dip the two wire separately in each and every container. First, let check the normal water, dip the wire. You will see the bulb is glowing. That means a normal water behaves as an conductor. Same way you can dip and check in lemon juice. Lemon juice is also acting as a good conductor. Kerosene is also acting as good conductor. But when you dip the wire without joining it together, just dip it inside the distilled water, you will see the current from one terminal is not passing to the other terminal while it is dipped in the distilled water, and the bulb is not glowing in case of distilled water. So we saw here that a normal water is a good conductor of electricity, and electric current could pass through it. Next to it, the liquid which conducts electricity and undergoes decomposition is, if you pass a heavy electric current through it, there might occur decomposition, means breaking of that liquid into its different component of which it is made. If we connect the two terminals of the electric source of the cell, or and dip it inside the electrolytic cell, or you can say a container, by a heavy battery, if we connect both the terminals and put both the terminals in the that container in which liquid has been taken, and we just take a metal and wound the wire which is coming from the negative terminal to that terminal and the positive to the next terminal, and dip the terminal both the terminal in the water. Next we will find that, and so the liquid which conduct electricity and undergoes decomposition. So the liquid through which electric current could pass, and that liquid start breaking into its two component of which it is made. That is, it is water is any water is made up of hydrogen and oxygen. So the water or the liquid that start decomposing means start breaking is called the electrolyte. The process by which the liquid is decomposed into ions is called the electrolysis. And the process by which, with what the element it is composed of, just like water is composed of hydrogen and oxygen. So hydrogen and oxygen in these two days breaks the hydrogen and oxygen in the form of ions. This is called the ions, in what component it will break, those components are called the ions. So when an electric current is passed, okay, the process in which the liquid starts breaking, the process by which the liquid is decomposed into ions, and these ions, the breaking of that liquid into its ions is called the electrolysis. Means when electric current is passed in the electrolyte, that electrolyte breaks, and the breaking of the electrolyte is called the electrolysis. Now, student, just I have told you, take two plates. When the heavy battery is connected with its positive and the negative terminal is connected, and dip into that electrolyte, just that wire, connect the wire with an you can say with a plate, a metallic plate, and dip it inside that electrolyte. So the two plates or rod dipped in the liquid are connected to the battery and called the electrodes. So just for example, student, connect it back with the cell, and this two rod are called the electrodes. Okay, student, these rods are called the electrodes. Next, student, so the two plates or rods dipped inside the liquid is called the electrodes. So these two rods which are dipped inside the water is called the electrodes. One is the electrode connected to the positive terminal. If suppose one is connected to the positive, is called the anode. Suppose that this is the positive terminal, this is the negative terminal. So the terminal that is connected to the positive is called the anode, and that is connected to the negative. That means this one is called the cathode. Okay, student. Anode and cathode. The terminal which is connected with that electrolyte, with that rod, that is called the anode, with the positive is connected, and if it is connected to negative, that is called the cathode. Anode and cathode. Anode means the positive one to which is connected, and cathode means the negative one. Okay, in which the negative charge is coming, and in that the positive charge is coming. So the electrode connected with the positive terminal of the battery is called the anode, which is connected with the negative terminal is called the cathode. The apparatus used for electrolysis is called the voltmeter, not a voltmeter. The apparatus used for electrolysis, and this apparatus what we are using for the method of doing the breaking the water is called the voltmeter. Okay, student. In such situation, the bulb may not glow even through the liquid is conducting. There are some cases that though the liquid is carrying the electric current, but the bulb which is connected to that wire is not glowing. Okay, when the electric current passes through the bulb, the filament of the bulb gets heated. So how the bulb glows? When the electric current when it starts flowing through its wire and it reaches inside the bulb, there is a metallic wire present inside that bulb that is made of tungsten. And when this bulb gets heated by the regular passing of the electric current, the filament which is present, which is made up of a metal like tungsten, when it gets heated, it start emitting light, start glowing. So the filament of the bulb gets heated to a high temperature, becomes white hot and start glowing out the light. So here you can see the heating effect of the electric. When the current is passed, that filament gets heated, and when it gets heated, it start glowing light, it start emitting light. So if the current flowing through the circuit is too weak, if the voltage is too low, if the power of the current is too low, then in that case, due to low electricity conductivity of the fuel liquid, then in that case the bulb will not glow, as because the current that is flowing to it is not so much powerful that it could heat up the filament of the bulb and let the filament glow. So heating effect produced in such filament is too little. That's why the bulb is not glowing. So thus the filament does not gets heated sufficiently and it does not glow. So a bulb cannot be used to detect the weak electricity current. So if you are using a bulb to detect whether the current is passing or not, so uh, there might be misunderstanding, because bulb doesn't glow in case of low voltage also. So low voltage means there is a current, but as because the current is of very low strength, it is not able to heat the tungsten metal of that bulb and the bulb is not glowing. So don't get confused that if the bulb is not glowing, it is only because of electric current is not passing. No, sometimes electric current passes, then also the bulb is not glowing as because of the low voltage. Okay. So thus the filament doesn't gets heated, and if it is low voltage, the filament which is made of tungsten, that will not get heated, and when it will not get heated sufficiently, it will not glow. So a bulb cannot be used to detect the weak electricity. So by the help of bulb, we will not get the correct information of the electric current flowing through a liquid or not. Thus, the weak electric current through the liquid can be detected in a two ways. So how you can detect? If you will take a big bulb, then it will create problem, because if it is low voltage supply, then it will cannot, it will not lit the big bulb. So in that case, either you have to apply the LED bulb, or instead of that you can apply the compass, because if a little bit also current will flow, the compass will deflect and will prove that current is flowing through it. Or that LED bulb can also glow at a very less volt, or you can say very less electric current supply. The LED bulb could glow. So LED bulb, or you can say magnetic compass, is better to prove that current is passing through that electrolyte or not. So example, LED means light emitting diode, can use to place the electric bulb. In place of electric bulb, you can use that this. As I have told you, in tester, the bulb that is present, that is also a LED, which glows a very less current, weak current. It also can glow. So slightly longer than next is that when even a very small current flow in a wire, compass needle kept nearby get deflected and thus act as a tester. So what I told you, that if the that by the help of bulb, if you want to check by the help of bulb, it might occur that if it is a low voltage, then the bulb will not glow, and in good voltage, high voltage, the bulb will glow. But this is not the sure test of current is passing or not, because sometimes happens that in the low voltage the big bulb will not glow, But instead of it, if instead of that big bulb, if you are taking a LED, or if you are taking a compass, that compass in such low voltage can deflect, or that LED can glow. This proves that the current is passing through that wire. So student, today up to here only. Next day I will explain the case of distilled water, tap water, sea water and rainwater. The current is in which the current could pass and in which it doesn't pass, and about the chemical effect of the electric current in my next lecture video I will explain it. Till then, thank you student. Have a nice day.